Hi guys, I will try to demonstrate in this short video why lithium batteries are better choice for energy storage than lead acid batteries. There is the misconception that lead acid are at least better option from an economic perspective, but as I will try to demonstrate here, it's a wrong assumption. I wanted to use multiple batteries on each chemistry in this comparison, but I decided that there is not a big difference and a large number of batteries may create confusion, so I decided to use just one example for lithium and one for lead acid. For lithium, I used the A123 systems, the 20 amp hour prismatic cell, since it's popular. You can find a good datasheet and I even own a few of them. For the lead acid, I chose the Trojan L16RE, since it's a popular battery, maybe not as popular as the T105 variants, but it has a better price for the amount of energy stored. The life cycle at 100% depth of discharge is more than 3000 for the A123 and less than 800 for the Trojan. Then energy that can be stored during the lifetime of the battery is more complicated than it's calculated here, but I want to keep things simple, so you get that by multiplying the 100% depth of discharge life cycle to the capacity in watt hour, and you will get the stored energy during the theoretical life of the battery. The price per installed capacity is what most of you take in consideration when purchasing a battery, and it looks like lead acid is almost half the price, but this is not the right way to compare batteries. A better way of comparing batteries is to use price per energy stored during the lifetime of the battery, and then things look quite different. Now the lithium battery is less than half compared to the lead acid battery. There are much more parameters that you need to take into account to make this an accurate number, like the charge-discharge efficiency, the battery degradation over time and other factors, but all this will make the lead acid look even worse in comparison with a lithium iron phosphate battery. There are numerous advantages in using lithium iron phosphate as energy storage, especially in solar application. One important one is that partial charge is desired in lithium iron phosphate but will deteriorate a lead acid battery. I will try to give some more advantages of lithium versus the lead acid batteries. One of them is that lead acid is extremely inefficient at charging and discharging, in average around 70% compared to over 90% for lithium. So you will need a larger solar array to cover these losses. Also a much larger battery capacity because of the losses, but also because the lead acid doesn't like to stay deeply discharged for long periods of time. Another advantage is that in cold climate you can just have the lithium battery inside with no venting, no gas get released during charging or discharging. For the lead acid, on the other hand, you need a vented box because of the hydrogen, and if vented you either have cold air from outside into the box that will dramatically affect the battery capacity and the life, or you heat the box, but that will require a lot of energy because of the venting. That energy can be significantly higher than what you use from the battery, so it will add to the cost of operation. Lead acid will also take more space and be much heavier. This is not usually a problem in a stationary application, but it may add something to the shipping cost.